Hey everybody, lesson 43. The first part we're going to talk about sine, cosine, and tangent. This is one of those things that confuses kids, has for 100 years or however long. But really, if you think about it plainly and simply, it'll start making sense to you in a lot better way than it did when I was your age. But just let's go back to this. These are two right triangles, and you can look at the one on the left. You can see that there's a 90-degree angle, there's a 30-degree angle. The other one, of course, must be a 60-degree angle. Because of whatever characteristics there are of right triangles, when you have a 30-degree angle, it'll, and the angle makes the side across from it how long it is, as long as the sides are closed in. And that will also affect, number one, the other, the 30-degree angle being 30 will make the other angle 60 degrees. And the length of the side, which is 2 across from the 30-degree angle, will also, that's what it's going to be. The angle measure will also not only affect the angle measure of the 60, well, the bigger an angle opens up, the bigger the side across from it as well. And we know from the Pythagorean theorem about right triangles, and you go a squared plus b squared equals c squared, the lengths of the sides. Well, at some point in the past, people started figuring out, wait, there's a ratio. If there's a 30-degree angle, this will be this, and oh, the ratio of this side of the triangle will be this to this side. And at some point, somebody was drawing a 30-degree angle every time and went, wait a minute, look at this. No matter how, I drew this 30-degree angle and the side across from it was 2, and I'll be darned, that is exactly half of the side length across from the 90-degree angle. And they went, no, let's try it again. Hang on, let's draw a big one. Okay, here's a 30-degree angle. I'm going to keep drawing this side, keep opening up till this thing is 60 inches or feet or whatever long. And they went, okay, now let's close it in and figure out what happens. They go, look at there. Look, the side, since we close, we'll stop this and we'll stop that. And this is, again, twice as long as that. So at some point, people started looking and going, so I guess angles will give you certain ratios of sides relative to each other. And, if you were to take 2 over 4 and do a decimal, of course it would just be 0.5. Same thing for a 60 over 120. If you did the same thing for 2 over, they figured out, oh, this is the length of this side, they measured it or whatever. Oh, this to this gives you another angle. Oh, let's see, 2 over 3.464 gives me this. And oh, 3.464 divided by this gives me that, and this, and so on. So they gave these things names. And just as an example of this, make up a length for the side adjacent to the 30-degree angle. Okay, well, it doesn't matter. You could, whatever. Let's just make this a 5, okay? Knowing this, that somehow every time we draw a 30-degree angle and the length of the side across from it is a certain number, we know that the one across from a 90-degree angle would be twice that. You'd think that it was 90 degrees, which is 3 times 30 degrees, you'd think it'd be 3 times as long, but it isn't. It's only twice as long, okay? If you were to figure out the 5 and the 10, you could figure out what this side was right here using the Pythagorean theorem. And we're going to be messing with a lot of actual decimals instead of a bunch of square roots when we deal with sine, cosine, and tangent. But you just need to write these 3 down and have them, just memorize them. And you'll start memorizing them pretty quickly, and you'll start using them, and it won't be that big of a deal. Sine, which is abbreviated with these 3 letters, looks like sin. Sine is the ratio of the side opposite of an angle to the hypotenuse of the triangle. Okay, so in other words, let's say the sine, you might see this, the sine of 30 degrees. And of course, don't forget, you can pause this thing and write down the definition. The sine of 30 degrees is going to be, we could call this x or whatever, and then this is the hypotenuse or whatever. We say the sine of 30 degrees is going to be x over the hypotenuse. The opposite, you just call it O for opposite, whatever. And opposite means, there is no magic opposite side. If you're talking about the 30-degree angle, then this is the opposite side, right here. If you're talking about this angle here, well then that is the opposite side. You don't have to worry about, oh no, did I get the right one? As long as you're looking at the angle, you can know which one is the opposite side. This is always the hypotenuse, because the hypotenuse is always across from the right angle. But the opposite side, whatever that is, that depends on what angle you're messing with. If you're messing with this, that's the opposite side. If you're messing with that angle, this is the opposite side. It'll always work out if you do it correctly. But just memorize that. Sine is the ratio of the opposite angle to the hypotenuse. All right? Second one is called, well, sometimes they do it like this. Sine is opposite over hypotenuse. You can write it like that. So if you just want to make yourself a note, S and then over H, you can do that if you want. Cosine is the second one. There are not in any particular order exactly here. COS is the way we define it, or abbreviate it. And that is the adjacent to the hypotenuse. In other words, you'll see it sometimes like this. The cosine of an angle, whatever that is adjacent over the hypotenuse. In other words, let's say you're messing around with this angle. Well, the hypotenuse doesn't change. That's still the hypotenuse. It's across from the right angle. But if you're messing with this angle, which side is the adjacent side? Wouldn't be this, right? That's the opposite of 30 degrees. So it would be this right here. That's the adjacent side. So at some point, somebody figured out that the ratio of a 30-degree angle, the adjacent to the hypotenuse, is point whatever it is. And we'll talk about that in a second. But so the idea is once you know a couple of sides of a triangle, you can figure out the other side without even using the Pythagorean theorem. And the calculator has buttons to do this, so you'll be in good shape when you find that out. Tangent is the third one. Excuse me. Tangent is the opposite over the adjacent. Opposite over adjacent. Sometimes it's, of course, it's TAN for tangent. That's the ratio. Opposite over adjacent. And again, don't worry about, oh, wait, which one is the, okay, I don't know, what angle are you messing with? You messing with this angle right here? Then what's the opposite of that 30-degree angle? Which one is it? Okay, it's this one, right? That's the opposite. Okay, what's the adjacent to this? That's the adjacent side. Now, let's say you were over here messing with this angle. That'd be a 60-degree angle, right? Okay, well, what's the opposite of the 60-degree angle? That, right? Okay, the hypotenuse would be still this. We don't care about that. But the adjacent would be this one, the one right next to it. So it just depends. Focus on what angle you're looking at. Then that'll tell you which one is opposite and which one is adjacent. Hypotenuse never changes. It's always the same thing. Okay, so on a calculator, how to find cosine, sine, and tangent. Every calculator is different. In fact, if you will take your phone, you can actually, let me just show you real quick. The calculator button on if you have an iPhone, it usually looks like this. If you hold it up like this, if you will turn it sideways, it opens up and gives you more options. Okay, you'll see it's a scientific calculator. And on that phone, if you want to do it that way, let me just show you my short method of doing this. You can look on the screen. You can switch to degree mode if you have an actual hand calculator. There's a DGR or DEG button on there somewhere. Once you do that, you enter the degree, like it says, find the cosine of 28 degrees. You would go 28, I'm going to do this myself, 28, then you would just hit cosine, and oops, I'm in the wrong measure here. I'm in radians, so I need to be in degrees. There I go, so I need to hit the degree myself. So hit 28, then hit cosine, and it should give you 0.88294 and so on. Okay. If you're using a calculator like on your computer, you can do this. You can go 28, then you can hit trigonometry and then cosine, and then you'll get the same thing, 0.882947 and so on. Okay. Let's say, for example, well, you guys do this yourself. Let's find the tangent. No, forget it. Let's find the sine of, I don't know, 70 degrees. Sine of 70 degrees. Okay. So in your calculator, I'll just do this for you. 70 here, I'll type that in. Then I'm going to hit the trigonometry. I'm going to hit sine. There it is. 0.9396. So basically, just do 2 decimals. That's plenty. So 0.94. Use that. All right. Let me try this also and make sure my calculator does it. So on your calculator, you'd hit 70. Then you'd hit sine. Bam. There it is. So 0.94 basically. Okay. One thing I want to make sure you understand is, let's say, we just said the sine of 70 degrees. I never understood this in high school, but I want you to make sure you understand this. Let's say this is a triangle. There's your 90. Pretend this is the 70-degree angle, okay? All right, that's the hypotenuse always, right? It's always the same thing, hypotenuse. The sine of 70. Now look back on your notes. What is sine? What side over what side? Okay, if you see your notes, it's opposite over hypotenuse. Okay, so the opposite of, there's your 70-degree angle. There's the opposite side right there. We'll call it O. All right. So what this number, when you type in sine of 70 and it goes, oh, the answer is 0.94. See that on your calculator? 0.93969 or whatever. Okay. When they say the sine of 70 is 0.94, what that means in plain English is this. It means that, and you can look at this as 0.94 over 1 if you want to. That matches this. In other words, if you have a 70-degree angle right here on a triangle, then the ratio of the opposite side to the hypotenuse is 0.94. In other words, this side here, the length of that side, is going to be 94% of the side of the length of the hypotenuse side. That's all that means. Okay, let's try one more. Just pop this in here. I'm just going to make something up. I don't know, cosine of 35. We'll try that. Cosine of 35. So in your calculator, go ahead and push 35 and then hit cosine. All right? And I'll do this on the big calculator. 35, trigonometry, cosine. Okay, boom. We'll call it 0.82. All right, so that equals 0.82. Now keep that in your head. Here's a triangle. Oh, that's not a triangle. There's a triangle. All right. Let's just pretend this is the 35-degree angle right here. Here's your, we know that's the hypotenuse. That doesn't change. Okay. Look in your notes. Cosine means what side over what side? What's the definition of cosine? Okay. That's adjacent over hypotenuse, or A over H. Okay. This is your 35-degree angle. What's the adjacent side? It's this one, right? Okay. So when you have a 35-degree angle, you can use your calculator and figure out that the length of this side right here, which the adjacent side, is going to be, now looking of course at this as a fraction, 8.82 over 1, this side is going to be 82% of this side, the hypotenuse, 0.82. That's all it is. And you'll memorize these three and use them over and over again until you're just sick of, you'll have them down really easily. The only thing is, the good thing is that your calculator does this. When I was your age, in trigonometry, I had to look in the back of my book. They had a huge, there was like 50 pages worth. Cosine of 35, cosine of 36, and it would just go, all these, you have to look them all up and use our finger and go page after page and figure it out. You guys just push a button. There it is. It's much simpler that way. So anyway, okay. We can go ahead and use a calculator, find the sine of 30. So go ahead and find your calculator, find the sine of 30. All right, I'll do mine here. 30, type in sine. What'd you get? It's a real simple number. Did you get it? Okay, it's 0.5. In other words, let's do 30, and the sine of that, trigonometry, sine, bam, 0.5. And don't forget what that means. You've got to understand what this means. The sine, you tell me, look at your notes. The sine is what over what? Sine is what over what? Okay, it's opposite over hypotenuse. Here's your hypotenuse. I don't know, let's say this is let's say this is 30 degrees. Okay, if that's your angle, what's the opposite side? That one, right? That's the opposite side. So what they're telling you, if you have a 30-degree angle, this side right here is 0.5. You saw the answer. It is half of the length of that side. We saw in a couple of examples of that exact thing a few pages back. That's all this means. When you type in sine 30 equals 0.5, that means that the length of that side over the length of this side is 50% of it, and that's it. They'll have things like 0.866 and 0.73 and 0.94 and 0.28 and all that stuff. That just means that's the percent of the side length that one is. All right, we'll forget this one for a second here. Let's go to the example we do in the book here. All right. Find the sine of A, the cosine of B, and the tangent of C. Okay, well, let's forget all these except for this one right here. Okay, the sine of A. All right, this is your A angle. Look again, what is sine? What over what? Okay, it's opposite over the hypotenuse. Will you tell me the opposite of A? What is that side? It's 4, okay? The hypotenuse is this, right? Okay, well, type in your calculator 4 divided by 7, and you'll get a decimal. Just do it to two decimal places, and you'll find that that is 0.57. All right, and there we go. Okay, let's do B, the cosine of B. Well, here's the angle B. The definition of cosine, look in your notes. It's what over what? Cosine is adjacent over hypotenuse. Okay. All right, that is the angle you're dealing with, cosine of B. So what is adjacent to B? This is next to it, but don't say that's adjacent because that's always the hypotenuse since it's across from the right angle. And that's going to be your, the adjacent. So adjacent over hypotenuse. So put in your calculator. This is a big calculator thing. You need a calculator with scientific functions on it, so make sure you have one, okay? So you're going to put 7 divided by 8.6, and that's we'll call it 0.81. And there we go. All right, let's find the tangent of C. Well, here's angle C right there. Tangent is defined as what over what? You tell me. Okay, opposite over adjacent. Well, opposite of C is 6. Okay, adjacent is 8. And you know, I'm sure, that's 3/4, so it's 0.75. So that is the tangent of C. All we're trying to do is go, oh, this angle gives us a certain length of a side by going whoop and going across from it. Okay, and once those we finish and make a triangle out of it, the length of that side compared to the length of this side, the hypotenuse or the adjacent to the hypotenuse, whatever, is point blah blah or whatever, and that's all we're doing. And we can actually go backwards, which we're going to do pretty soon here. I'll go, this is the cosine of this angle is 0.98. Okay, what kind of an angle will give you that ratio? And then we'll go backwards and find that out. Okay, all right, and let's do it. So the sine of 30 degrees is 0.5, right? So the inverse sine of 0.5 is 30 degrees, okay? So we're going to go back and forth on these, and I'll show you how to do this, okay? How to find the inverse of a cosine, sine, or tangent of a number. Here's how you do it. Now, again, your calculator might be a little bit different, but that's okay. You'll find the buttons to push or whatever. All right, so you type the number in the calculator. This is the ratio of the side lengths, not the degree. In other words, if somebody says to you, oh, a minute ago I found out the cosine of blah, blah, blah is 0.82, which we did just a few minutes ago. Oh, 0.82, we got it, okay. Well, now we can find out, if you look back at this, we found, it's 0.81, we'll call it, all right? So now we can look at this triangle and go, oh, well, since the so-and-so is 0.81, now we can find the angle measures of this and that. Interesting, okay? And you work backwards and you push another button, all right? So you type in the number in the calculator, in other words, let's say 0.82. Then you hit INV or inverse, or it might be this. It might be second or 2ND on that to show you that you're not just, you're not doing the original when you're going backwards. Then sine, cosine, or tangent. Okay, so I'll show you how to do this. And the answer will be the degree. But previously, we got an answer like this, and that showed us that, oh, the side length of this compared to the side length of that was 0.82. This side length was 82% of that one. Now what we're going to get, when we type in this part first, the ratio decimal, we're going to go type another button and we're going to go, oh, it'll give you 38.3, which will be 38 degrees. That'll be your degree measure. So let's do a couple of these. Find the angle whose sine is 0.643, and let's break this down. Okay. So here's a triangle. There's your right angle. There's the hypotenuse. Okay. Let's say there's an angle. We don't know what it is. We don't know what the angle is. But the sine is 0.643. In other words, let's say, first off, you tell me, the sine by definition is what over what? Okay, it's opposite over hypotenuse. So in other words, the opposite of this, whatever this angle is, it gives us a ratio of 0.643. So we could say 643 and the hypotenuse would then be 1,000, right? That's a ratio of 0.643. You see that? Okay. The only thing, of course, we can use the Pythagorean theorem to find out this third side length as well. The only thing is we don't know what kind of an angle gives us, opens up enough to where the ratio is 643 thousandths. Well, that's where you actually type in your calculator. And let me do this on the big one so you can see it a little better. So we'll go 0.643, and then we'll go we'll go second. And I don't know if you notice this, but when you push second, a little like an exponent with a -1 appears. Now that is your symbol and your signal and your clue that you're going to go backwards. You're going to go from I got the ratio of the sides as a decimal. Now I'm going to figure out what kind of an angle gives me that ratio. Okay, so you push sine, bam, and there it is, and you got the answer is 40. Well, what that tells you is, if you want an angle that gives you a ratio of 643 thousandths of opposite over hypotenuse, this angle better be 40 degrees. And that's what it's going to give you. That's going inverse function, which means, of course, this will have to be 50 degrees here. Now here's something funny, okay? Let's do this. Here's another strange one for you. We can actually do more in this. Let's pretend like you didn't know this was 40, but you knew this was 50. Well, we know it's 50 based on this, and that being 40. Okay, so let's look at this. 50, we're going to mess with this angle, right? All right, we can find out the angle of 50 will be the adjacent, right? If we're messing with 50, this will be the adjacent side. That's still the hypotenuse, correct? Okay, so adjacent over hypotenuse, that's not the sine. What is the definition for adjacent over hypotenuse? Which one is that in your list of three? Sine, cosine, or tangent? If you look, it's cosine, right? So cosine is adjacent over hypotenuse. Well, in your calculator, let's type in. Let's just go like this. 50, oops, I typed in a 50 and 60. Oops, I want an original. Oh, wait a second, it's already gone. So okay, here, 50, I just typed in 40. And then, excuse me, we'll go cosine. Well, look at that. The cosine of 50 is 0.642, I mean basically 0.643. Well, that just proves we did it right. So you don't have to be worried about, oh no, which one should I use? Whatever one you want, whatever one you can do. I mean, if you have two excuse me, choices, pick one of them, who cares? All right, let's do another one. Find the angle whose cosine is 0.216. In other words, there's your triangle. All right, there's your hypotenuse. Let's say this is your angle that you're messing with. You don't know what it is. The cosine is 0.216. Let's think about cosine. Cosine is what over what? Adjacent over hypotenuse. In other words, this to the hypotenuse will be 0.216. In other words, what angle will give us, some measurement where the adjacent, let's say, is 216 feet as opposed to 1,000 feet, which I didn't draw this triangle even close to being right. But anyhow, what kind of an angle will give us that? Well, again, we'll go back to this and go 0.216, and we'll go to the trig function. We'll go second, and then we'll type cosine. In other words, we're asking the calculator what kind of an angle will give, how open does the angle need to be, to give us a ratio of where the side next to us is 21.6% of the hypotenuse. You click it, boom, and there it is. That's going to be 77.5 degrees. 77.5 degrees. So that'll be 77.5. And knowing that, you can figure out what that angle is just by going 90 plus that equals 180. With this included, you can go Pythagorean theorem and find out this side here by just squaring it and all that kind of stuff. Other things you can do as well. Okay, well, let's try the practice set and go ahead and hit pause and just and your calculator, go ahead and use this. All this means right here where it says 4 cosine this and that, it just means find the cosine of 75.8 degrees, get it, and then multiply it by 4. That's all you need to do. Okay, so pause it and do A. Okay, so A, I'm going to put in 75.8. That's the, okay, is that right? Degrees. Cosine of 75.8, and then I'll go trigonometry. What's the cosine of 75.8? Boop, 0.245. All right, I'll multiply that by 4, and that gives me, excuse me, equals 0.98. So the answer to this would be 0.98. All right, go ahead and pause it and try B. Do the same thing for B. All right, I'm typing in 37.42. Or they want sine, okay. Trigonometry, what's the sine of 37.42? Boink. Okay, 0.607. In other words, if you have a triangle and one of the angles opens up 37.2 degrees, then the opposite over the hypotenuse will be 0.607. So the side across from the sine will be like 60.7% of the hypotenuse, all right? We're going to multiply that by 6. And that'll give us 3.64, I guess. Okay, 3.64. Okay, all right, pause it and try C. Okay, for C, the sine of C, we have to memorize, and you look at your notes as much as you want. You'll get it after a while. The sine is the opposite over the hypotenuse. All right, we're looking at this. What's the opposite of that? It is 3.61. All right, well, 3.61 over 7.52. That's our answer. Oops, 3.61. 7.52, boom, 0.48. So the sine of C is 0.48. All right. The cosine of D, go ahead and pause it and find that. Okay, here's D. The cosine is defined as the adjacent over the hypotenuse. So the adjacent to D would be 3.63. The hypotenuse is 4.76. You'll divide those two. So 3.63 divided by 4.76, oops, 6, is 0.76, we'll call it. Okay, so there we go. And that's it. Okay, now pause it and try to find the tangent of E. There's angle E. What's the tangent of E? Okay, tangent by definition is opposite over the adjacent. All right, well, what's the opposite of E? 8.73. What's the adjacent? 11.30. All right, so what? 8.73 divided by 11.3 is 0.772. Okay, so there you go, 0.772. All right, by the way, let's just for the heck of it, okay, this is not your thing. Let's find out what kind of an angle, what could angle E be? What kind of an angle opens up and gives you a ratio of the opposite side over the adjacent side as 0.772? How do we, let's figure out what the angle is. Let's go, in other words, let's go backwards, right? Let's do the inverse, okay? So there's my, it's 0.772, it's sitting there, right? I'm still in my calculator, right? I'm gonna go to second, right here, oops, trigonometry first, second, I'm already in second, okay? And then I will find the tangent, right? Because we're doing tangent, right? Okay, so what kind of an angle gives me, you know, a ratio of the opposite over the adjacent is 77.2%. Boom, there it is. The angle is 37 we'll call it 7. So this angle is 37.7 degrees. All right. This one, if you do the arithmetic, if you just went that, you know, 37.7 plus 90, okay, equal, is that. And then you could figure out that, okay, well, this has to be 52.3 degrees. In other words, this last one here has to be 52.3 degrees. Okay? Well, let's just check it out. Let's find out if it is 52.3 degrees. Let's see if it works. All right? What we can do now is we can go, okay, Any angle you want to mess with, anything you want to do, sine, cosine, tangent, doesn't matter. Who cares? I don't know. Let's take, let's take this angle. All right. Let's say opposite is 11.30. And that's the opposite. Hypotenuse is, of course, that, right? 14.28. Okay. Well, what is the definition of opposite over hypotenuse? Which one of those do we call it? Okay, that's sine. Okay, so in other words, we're going to figure out 11.3 divided by 14.28, right? Is that 11.3, 14.28? We get that right there. Okay, now we're going to go, okay, well, since that's opposite over hypotenuse, that's called sine. Okay, we'll go over here and we'll go, okay, fine. What's the inverse of sine? In other words, what kind of an angle gives us a ratio where that angle goes out and the opposite of that angle over the hypotenuse, the ratio is 79%, okay? Well, we can push the button. That's a sine. You ready? Doink. 52.3 degrees is what they tell us. Well, that's exactly what it's supposed to be, remember? 52.3 degrees. Anyway, that works. That kind of stuff is interesting. All right. Last two, find the angle whose tangent is 0.405. Well, again, you're just going to point in at 0.405. And the tangent, we're going to go trig over here, second, and then the tangent, doink. That's a 22-degree angle. So a 22-degree angle, let's say here's a triangle. Let's say this is 22 degrees, right? The definition of tangent is opposite over adjacent, right? If your angle here is 22 degrees, then this side length right here is going to be 40.5% of that length right there. That side length will be 40% of that side length. That's just the way it does. Okay? Find the angle whose sine is 0.794. Okay, in other words, here's a triangle. That's a horrible triangle. Okay. Here's an angle. The sine is defined as what? You tell me. What's a sine? What over what? Opposite over hypotenuse. Okay. In other words, they're asking, what's this angle? We know if we open it up, it gives us, this is, 794, and the hypotenuse is 1,000. Oh, that's the ratio, 0.794, right? What kind of an angle is going to give us that kind of a ratio? Well, you plop it in the calculator. 0.794. And then we got trigonometry here. We got second, sine, bam. 52 point, we'll call it 6. So that's a 52.6 degree angle right there. That gives us that. So, okay. All right. Hope that wasn't too confusing. Just remember all these numbers you're getting, this number here, that number here, that is just the side length of one divided by the side length of another. This side length is 40.5% of the other side length. This side length is 79.4% of the other side length. That's what sine, cosine, and tangent are all about. Okay, thanks.